So when I look at example 10, I'm going to get to, if you're asked to write the equation of a conic section, then typically you're going to end up writing it in one of those standard forms that we just showed on those previous two slides. What you're being given is information that you're going to basically fill in puzzle pieces, okay? And as you fill in each part, you're getting closer and closer to the final result. So, when I look at a problem like this, I want to kind of dissect it. This says I have an ellipse with a center at negative 5, 2. Endpoints of the major and minor axes, which are going to be basically to help me determine my A values and B values. As I say this, I wanted to point out, I think it says in those notes that I have, there are some slight differences between how I'm going to show how some of these formulas work and what A and B stand for than what the textbook says. The textbook for ellipses will always let A represent the major axis information and B always represent the minor axis information. So A is always going to be the bigger one. Okay. I choose to go with the route of saying A is always going to be horizontal, B is always going to be vertical. You can tell which one represents the major axis because it's going to be the bigger one. So it doesn't create any major difficulties when you're doing problems like this because you're still going to get the same formula when all is said and done. This is I may call something A that they'll call B, but the numbers will still be put in the right places. It's just like just interpreting it a little differently. So, as I said, since these are endpoints of the major and minor axis, that's going to help me figure out what my A and B points are. And if I have those, that's going to help me get everything I need to write the equation of my ellipse here. So let's go to it. First, I'm going to start with this. That's the format I'm going to be following, because that's the standard form equation of an ellipse. Now, when I'm done, h and k, as well as a squared and b squared, are going to be replaced with numbers. Everything else is going to be where it is. The one on the right, the plus sign, the fraction bars, the parentheses, the x and y's. The minus signs might change because if I have a negative coordinate for that replaces h or k, that might change the sign. Keep that in mind. But let's fill in the information. The center is at negative 5, 2, which means that I'm going to replace h with negative 5. And as you see, what I did there is, since I'm subtracting a negative 5, it's like adding 5. And k is going to be 2. So I'm going to have y minus 2 in there. So I got those two numbers filled in. What you see me doing up there is a really crude graph, but I'm doing that to kind of get an idea of how things relate to each other. I plotted where the center would be approximately, and I'm showing where the other points are with respect to it. So like for instance, 0, 2, would be over on this part right here. I don't have them labeled, but here's where 0, 2 would be. Right there, where X marks the spot. And I can see how far to the right that is from my center. And it is right from center. It's 5 units right from the center. And when I have some of the other points like negative 5, 17 and negative 5, negative 13, I can see how far that is. Those are from the center. They're 15 units away from the center. So I know that my A, because again, I let A be horizontal only, is 5 units. B equals 15 because it's vertical. That's the way I define them, at least. Again, your textbook would forcibly call A 15 and say, well, here A goes underneath the Y. And in some cases, A is going to go underneath the X. I said, no, it's confusing that way. A always goes underneath the X because A, H, and X are all information that's horizontal, whereas Y, K, and B is always going to be vertical. And I've taught it that way for several years, several classes, and I have had most people say that they found it was easier to remember it that way, especially if they had trouble with this kind of stuff in the past. So take my difference to heart. If you're still comfortable with the way it had been done, you remember it before, by all means use it. It doesn't bother me. But I know A is 5, so I'm going to have 5 squared on the bottom. I'm going to have 15 squared on the bottom underneath the Y. And of course, I should evaluate what those are. So my final answer would be this. X plus 5 squared over 25 plus y minus 2 squared over 225 equals 1. A hyperbola with center at negative 3, negative 5. and a vertex at -3, 0, a co-vertex at 0, -5. Now, again, this is not necessarily all the information you might be given for hyperbole. You could be given different information, and some questions actually give you information about, the asymptotes. And one of the things we do mention about when we draw a hyperbola is, constructing the asymptotes. But be that as it may, I have, the center, I have the vertex, and I have a co-vertex. Now, a vertex would be an endpoint of the transverse axis. Um, but the transverse axis is vertical because when I look at the relationship between where the vertex and the center is, one's underneath the other. So that means that, because the vertex is actually above the center. So the transverse axis is vertical. Your textbook would force anything about the transverse axis to be A and anything about the conjugate axis to be B. But again, I go with vertical and horizontal, and I don't have to keep track of which one is, going to go under which letter, or A is going to go underneath the X or the Y. Well, for me, A always goes underneath X. A is always horizontal. I could tell you which one's the transverse or conjugate axis just by looking at the formula when all is said and done. Because the reason why I want to determine this, and I can already see what my A value and B values are, because I have my horizontal and verticals. That's another thing I think it also helps in mind, because you get the information a lot faster about horizontal versus vertical than you do about transverse versus conjugate. But the reason why it's important for me to note that the transverse axis is vertical is that means that, because I have two different equations for for a hyperbola. Either the x stuff comes first, the x minus h squared over a squared comes first, or the y minus k squared over b squared comes first. That's what communicates which one's the transverse axis, which way the hyperbola is going to open, because subtraction is not commutative. So that's why I cannot reverse a subtraction without there being some fundamental change. And so because there is a subtraction involved, that's why I have two different formulas. And with the transverse axis being vertical, I know that this is going to open up and down, which means that that's the formula I'm going to want to be using. Now I know what h and k are. H is -3, k is -5, so I put them in there. A is 3, so a squared is 9. B is 5, so b squared is 25. And you can see where I put them in with respect to each other. That's your equation. That's it. A parabola with a vertex at -6, 5 and a focus at -4, 5. So it opens to the right, because I can see where the vertex is, where the focus is. So the vertex and the focus are both going to be on the axis of symmetry. So I know it has a horizontal axis of symmetry, and if it has a horizontal axis of symmetry, it's going to open left or right. The parabola also has to surround the focus. The focus cannot end up being outside of the parabola. So I know this is going to open to the right, which tells me A is going to ultimately be positive. I know where h and k are, because h is going to be -6, k is going to be 5, so I can put those in right away. That's going to do some sign changes on the outside there. What I have to do now is actually calculate what A is. Now the focus helps me with that, because I can see, that there's a formula that says 1 over 4A is the distance between the vertex and the focus. And I can see when I go from the vertex to the focus, that's 2. So 2 is going to equal 1 over 4A. And as I carry through the calculations, I get that A equals 1/8. And therefore, I can now replace A with 1/8. I can make that plus a -6 and -6, and there's the equation of the parabola that fits that description.